So we're moving on with our investigation of polynomials, and we're going to be adding and subtracting polynomials in this video. Remember, we can only add or subtract like terms. So that's the most critical thing, and that's why it's highlighted and underlined. We can only add or subtract like terms when we're adding and subtracting polynomials. Now, we've been combining like terms, better known as CLT. We've been doing that since the very beginning of Algebra 1 and when we were solving equations. And order of operations still applies. Combining like terms still applies. When? Forever. As long as you are solving algebra problems, you're going to be combining only like terms, and you're going to be following order of operations. So I've got some examples to flip through, and then we're going to get into some more that are more involved. First of all, if we have 1x plus 3x, how many total x's do I have? I have 4x. Remember, when we add or subtract, the exponents never change when we add or subtract. Exponents only change when we multiply or divide. Again, 6x squares minus 3x squares. How many x squares remain once we take away those 3? 6 minus 3 leaves 3x squared. Again, the exponents never change. 7xyz's plus 11xyz's will give us 18xyz's. The exponents never change when we add or subtract. We only add or subtract the actual coefficients in front of the like terms. 1 plus 3 is 4. 6 minus 3 is 3. 7 plus 11 is 18. Now finally, this last one. We've got two terms here. One is a variable expression. One is a constant. Can we combine like terms here? No, it's already in simplest form. So 3x squared yz minus 1 cannot be simplified. It just remains 3x squared yz minus 1. We cannot combine anything there because there are no like terms. So one more time, adding and subtracting polynomials, we can only add or subtract like terms. That's it. So we're moving on, and we're going to be adding these polynomials. I'm going to show you two different ways. The first way is just to do them horizontally. Now, we're going to see lots of problems in the book where they give us a quantity plus another quantity. If all we have there is a plus, do we really need the parentheses? No, we do not, because this is just straight addition all the way across. So if you want, you can even just get rid of those parentheses. It just doesn't matter as long as it's a plus sign in between them. Now, anything else, the parentheses are very important. If it's just a plus sign, then we can go straight across from left to right and find the like terms. There's an x cubed. There are no other x cubes. Here's an x squared. There's an x squared. Here is an x. There is another x. And then finally, we have the two constant terms. Now remember, we're going to simplify by combining like terms, and we're going to leave our answer in descending order, which is standard form for polynomials. So this is the only 4x cubed, so just bring it straight down, and we're done. 12x squared plus 5x squared is 17x squared. I will say again, the exponents never ever change when you're adding or subtracting. Positive 8x minus 6x, that is plus 2x. And then lastly, our constants, 6 plus 9 is 15. So this is our answer in standard form, descending order. Now, the other way to do this problem would be in a vertical format. So this was horizontal. Horizontal was just worked from the left to the right. Now, if we put things in a vertical format or a vertical algorithm, we're just going to line up our like terms vertically. Now, we can go straight from where I have them all highlighted as to what is what. So here's 4x cubed. Nothing's going underneath it because nothing is getting added to it. Then we can have a positive 12x squared and a positive 5x squared. I'm simply lining up those like terms vertically. Then we could have a positive 8x and a negative 6x. And then finally a positive 6 and a positive 9. Now our like terms are lined up vertically and we can just add down the columns. So adding 4x cubed plus 17x squared plus 2x plus 15. Same exact answer, except this time we have a vertical format from the top down to the bottom. Second question, adding once again. This time I'll set it up straight away in a vertical format. Once again, if we are adding, do we need the parentheses? No, we can drop them. So negative 7x squared and a positive 1x squared. A positive 2x and a negative 2x. And then one constant, a positive 5. I've got them lined up in a vertical format. I can add straight down the columns. A negative 7 and a positive 1 is a negative 6x squared. Notice once again, whoop, I missed my x squared. That should be there. Our exponents never ever change when we add or subtract. Next, a positive 2x and a negative 2x. These two terms are opposites. So when they're opposites, does anything remain? No. 2x minus 2x cancels completely, so goodbye x's. Bring down that constant, plus 5. Our sum, because we are adding, is negative 6x squared plus 5 in descending order in standard form. That's number 2. Number 3 has 3 quantities, but the procedure's not going to change. So I'm going to line them up in a vertical algorithm. 6x cubed, there's only one. There's a 3x squared, there's a 3x squared. Both are positive. Remember, if it's plus is in between those parentheses, we really don't even need them. So plus 3x squared and another 3x squared. Next we've got a negative 4x, a positive 2x, and a negative 4x. Line them up vertically. Mind the signs in front of the terms. Minus 4x plus 2x minus 4x. We're lining up the like terms vertically. And then finally, a positive 7 and a positive 4. Plus 7, plus 4. Everything's lined up vertically, and we can go from the top down to the bottom. So nothing to combine here, so bring down that 6x cubed. A plus 3 and a plus 3 is a plus 6x squared. Once again, I'm adding the like terms. The exponent stays exactly the same. A negative 4, a positive 2, and a negative 4 is negative 2 minus 4. That is negative 6x. Exponent does not change. 7 plus 4 plus 11. This is our sum. Now we're going to move into subtraction. Subtraction, we do need the parentheses because something very important has to happen first. Whenever we have a minus sign that is directly in front of parentheses, so we see it right here, minus parentheses. What we've got to think about is that a negative 1 is there and it must be distributed. So write in your notes, distribute negative 1 when we have a minus is right up against our parentheses. We've got to distribute that negative 1. So basically by distributing that negative 1, I'm really following order of operations because order of operations says that we need to multiply or divide before we add or subtract. So when I distribute that negative 1, I'm going to get a whole new problem. So here's my first quantity. So 9x squared plus 3x minus 7. Now take that negative 1 through. Negative 1 times negative 6x squared plus 6x squared. Negative 1 times 3x, negative 3x. Negative 1 times negative 5 plus 5. So here is my new and improved problem after I dealt with the minus parentheses, which is the same as distributing a negative 1. So now we're going to line up our like terms. So I'll just do this one horizontally. There's an x squared, there's an x squared. There's a 3x, there's a negative 3x. There's a constant, there's a constant. So from here, add the like terms. 9x squared plus 6x squared is 15x squared. Once again, the exponent never changes when we add or subtract. Mark them off. 3x and a minus 3x. These are opposites. They will cancel completely. Lastly, negative 7 and a positive 5 is negative 2. That is the simplified form, and that again is done in a horizontal format. Your choice, horizontal or vertical. Once again, I've got a negative 1 that's in front of those parentheses. It must be distributed. So my new and improved problem, 6x cubed plus 3x squared minus 9x plus 2. Now take the negative 1 through using the distributive property, following order of operations, negative 7x squared, negative 1 times negative 3x plus 3x, negative 1 times positive 1, negative 1. Let's line up those like terms. We've got only one x cubed, but then we've got an x squared and an x squared. So plus 3x squared minus 7x squared, lining them up vertically this time. A negative 9x, a plus 3x, minus 9x, plus 3x. And then finally a plus 2 and a minus 1. Be mindful of the signs in front of the numbers. Plus 2 and a minus 1. Everything's lined up vertically. Add down the columns. Bring the 6x cubed down. 3x squared minus 7x squared, negative 4x squared. A negative 9 and a positive 3 is a negative 6x. Once again, exponents never change when adding or subtracting. A positive 2 and a negative 1 plus 1. That is our final difference because we subtracted. Last problem. Everything going on here, all at once. So remember, we're always going to follow order of operations. So G, E, N, S. G is for grouping symbols. We have grouping symbols, but when we take a look inside the grouping symbols, can we do anything? No. So then we go to the exponents. Do we have exponents? Yes, but they're inside of the grouping symbols and we really can't do anything with them. So then we go to the M, multiply or divide, and that we can do. We are going to distribute, not once, not twice, but 3 times we're going to use the distributive property before we add or subtract. So let's take the negative 2 through. Negative 2 times 3x squared is negative 6x squared. Negative 2 times negative 4x plus 8x. Negative 2 times 1 is negative 2. Next, 3x is being multiplied through. Pay close attention. This is 3x to the first times 2x to the first. The exponent is going to change here because we're multiplying two terms that have the same base. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Last set of parentheses, take the negative 1 through. Negative 6x squared minus 3x plus 1. Let's do this one horizontally. Let's find the like terms. So here's an x squared, here's an x squared, here's an x squared. There's an X, and an X, a constant, and a constant. Let's combine like terms. We're finally doing the S in order of operations. So negative 6x squared and positive 6x squared cancel. But there's still one remaining x squared, so bring it down. Next, 8x minus 9x is negative 1x. Negative 1 minus 3 is negative 4x. Exponents only change when you multiply or divide, not when you're adding or subtracting. Lastly, a negative 2 and a positive 1 give us a negative 1. And this is our final simplified polynomial following the rules for order of operations and combining like terms.